Welcome to the 35th episode of the Tesla Tomorrow's podcast. And this is our second Robotaxi Countdown episode. This is a series until the Robotaxi launch in June by the FSD unsupervised Robotaxi launch that will be taking place in Austin, Texas. And today we are very honored to have Phil Beisel entering as a guest to this episode. For those of you who do not know Phil, Phil has been writing extensive articles about not only FSD but also Optimus, but mostly it's Tesla and AI related. I can highly recommend checking out his articles. And Phil, first of all, very happy to have you on this episode. Finally, some real deep dive into the tech of FSD. But it's not all about Tesla, because you have worked at Apple, but you are also a former Rivian employee. And I saw that you worked there or were responsible for Future Labs. So, first of all, can you tell us a little bit more about yourself and what you did at Rivian?
Sure. Good afternoon. So I work and live in Silicon Valley, and I've been here for quite some time. I've worked at Apple twice in my life. In 2017, I went to Rivian as a founder of the technical team, and this was to define and develop the software-defined architecture of the vehicle platform, and through that built teams on both the application side, which is what you see in the car, as well as the kind of architecture of the vehicle, electric architecture of the vehicle, and as well as the Rivian Cloud team for data, big data system, mobile team, and then after doing that, was at Rivian for about 6 years. I founded a futures team focused on just kind of innovative ideas surrounding the vehicle space, and yeah.
Phil, you worked on let's say very innovative companies with Apple and Rivian, and if you looked at the electric vehicle adoption from, let's say, the more traditional OEMs, you see, from my point of view, very much when we were there 10 years ago, very much underestimated the difficulties of building an electric car. You touched upon some the two lines that you've been working on with Rivian, but I think the philosophy how Elon explains it, like electric cars are more or less computers on wheels. If you compare to traditional, car makers, can you explain roughly what the difficulty is in getting electric vehicles on scale when it comes to manufacturing and software?
Yeah, well, I'll speak to the software side of it. I mean, I think obviously electric vehicles are in fact computers on wheels. I mean, they provide, but by the nature that they're electric is not the defining element, obviously, for building this software-defined architecture. But it is different than traditional auto. Traditional auto very slowly put electronics in the car and wired that together, and you could see that as an evolution. And then kind of the state of the art with that is the what's called CAN architecture of a vehicle. I think it's called Common Area Network, which is a small bus network in vehicle. And all these things progress somewhat slowly in the space of trying to approach something that's more like a modern consumer electronics device. When I came to Rivian, the team was founded in Silicon Valley, and very purposefully so. The idea was that we would have free reign to literally define this software architecture and envelop the car as in that architecture. And so from even sort of the electronic side and the networking side. I mean, you're talking about now you move from this sort of archaic CAN model vehicle to a modern gigabit Ethernet backbone. You define ECUs, electronic control units, that are much higher level of functioning, not just like door controllers and simple things that actuate, you know, not inputs and outputs to the vehicle, but really building an entire user interface. And so, it wasn't by accident that when I went to Rivian, I had no vehicle experience. I just had software experience coming from Apple and understanding sort of how Apple put together, combined software to hardware, where the software defines the approach. And so this was great because, I mean, it really wasn't a limitation. It was an opportunity to then literally redefine this. And so, what we're left with today, across the world, is legacy auto that is still, kind of incrementalizing themselves into these future state. And in my opinion, that's not satisfactory. It's not high enough velocity. And then companies like Tesla and Rivian, who have really redefined the landscape. And so to me, it's like akin to flip phone to iPhone, change up. And I think that, that's where we find ourselves, is that we really do have a modern electronic device, computer on wheels, and of course with Tesla now we have a robot on wheels. So it's quite exciting.
Yeah, definitely. And like you've worked at Rivian. How long has that been? You started there 2017, I believe.
Yeah, I started in 17 and left about 6 years later. And yeah, it was quite a journey. I think when I started at Rivian, we were roughly 50, 60, 70 employees. I didn't really pay much attention, but about that. And then when I left Rivian, we were about 14,000 employees. So it was very, very, quick development, a lot of capital infusion. We built 2 vehicle platforms and 3 total products on those platforms in what amounts to about 5 years to production. Now the company started before I got there, but it really got going in earnest on its current mission about when I got there. And we had very little. I mean, I shouldn't say that. We had very little. We certainly had very little in terms of what we were doing from a software and hardware perspective when I showed up, because literally, it was a team of 5 of us that started that group from a hardware software perspective, and got it going.
That's some impressive growth. But what makes me more curious is, like, your visibility on X is mainly in the Tesla space right now.
Yeah.
So can you explain a little bit more about where that passionate drive comes from, by explaining and educating people online about the magic of FSD or all the other articles that you've written?
Sure. I mean, when I left Rivian, now I have a great relationship with the company and know the CEO very, very well, and it's great guy. RJ's an amazing guy. I just decided that I would take a very agnostic approach to the space, the technology space, and I got interested in Tesla. It's interesting. Oddly, you might find this a bit odd. When I was at Rivian, I had very little interest in the technology of Tesla. I mean, what I'm saying is, the tech teams at Rivian didn't do a copy paste at all. In a way, we kind of ignored Tesla for the most part and did our own thing, which was, I think, kind of important. Now, when I left Rivian, and now I was able to look at all things, and I looked at Tesla in the space, and what's always interested me about Tesla is just how defining they are in the industry, and any place that they go, whether it's energy, humanoid robots, obviously electric vehicles. So I became interested in the technology that they're developing for vehicles for humanoid robots. Probably Optimus is my favorite topic and favorite thing I'm most interested in. But I think that FSD kind of grabbed me because when I came to Rivian, one of our sister groups was ADAS, the autonomy group, and I always looked at that and said, "Gosh, that's hard." I mean, like, yeah, my job's easy compared to that, and this is going back many years, and I would say every time we would, one of the goals, one of the things that you do that you wish you didn't have to is when you're building these teams at companies like Rivian is recruiting. I mean, you spend a lot of time recruiting, hopefully, young smart minds and some old smart minds as well. And as we would go to college campuses, the Berkeleys and the Stanfords, and constantly, students that were, graduating, looking for internships or full-time jobs, would always talk about vehicle autonomy, the robotics projects that they were involved in, and it always, it's kind of like, oh, it was a little deflating because, from my point of view, is like I'd be hiring into a group that doesn't do that kind of thing, and they're earnestly telling me about these great projects excitedly telling me about these great projects they worked on in some kind of robotics or autonomy, and I realized, to the outsider looking in to these new companies that are doing vehicle autonomy was a very defining thing, from a technology point of view. And most people just didn't really recognize there's so much more to the entire electric architecture of these vehicles, right? So that got me very interested, but not interested enough to do anything about it, because obviously I was quite busy with my own job, and I would poke my nose often into what the autonomy team was doing, and I would look at their cars and see how they built up their mules with these kind of prototype cars with the different sensor sets, and we would talk about these sensors and talk about cost profiles and capabilities, and the defined level 1 through 5 autonomy, and so I was obviously very interested in that. In fact, actually quite relieved I wasn't working on it to a certain extent, because I always thought, wow, what a job. You got to build something that is sort of thankless. The thing it must do is not kill you. I mean, it must be safe. And how well it works beyond that and then was not considered, so the idea that you would build something that has great fluidity and change lanes beautifully, it was more about safety first, and that type of thing. So long story is, when I left Rivian, I became very interested in FSD, and for the first time in my life, I think I've been in a position of trying to reverse engineer something. Mostly I've been on the front end of that type of thing, building something and then listening to others talk about what I built, maybe externally, outside of, say, Apple, outside of Rivian. Here I have this position of looking into Tesla and kind of reading the tea leaves and trying to figure out what they did. I come away very impressed. I think, yeah, extremely impressed that they've grabbed onto this philosophically as principally a vision-only model,
Yeah.
and have built something that does what it promises.
Yeah, yeah, especially
you touch upon the complexity of building something like FSD, and sort of the unthankfulness of just it needs to be so safe, and you put it out there, and everything that is not coded correctly can potentially be led to thousands of dead people. So I always felt that, well, wow, this is such a big risk the company is taking, and obviously Elon has been underestimating the complexity of full self-driving as well, because in 2060 you already launched the first autonomy day, and after that it became a sort of golden Elon thing of, okay, this is the year of full FSD, this is the year that it's
Right.
ready.
Right.
And he talked about sort of the final sort of 0.1% being ironed out in that thing. When you looked at the complexity of this full self-driving system and trying to reverse engineer it, what have you been considering as the big bottlenecks or complexities that Tesla is able to solve over the last, let's say, 2 to 3 years?
Well, it's what, obviously, the biggest thing that Tesla did moving from the what I call pre-version 12 world of FSD, version 12, 13, and then coming 14 is end-to-end AI. And I think I kind of watched that develop over time. AI from the idea of doing using machine learning for perception, which is, if you think about full self-driving, there's really two aspects of what it's doing. It's perception and planning. Perception side, which is understanding its environment, its scene, what it's seeing, what's dynamic and what's static in that environment. In other words, cars, vehicles, etc. And then the planning side, what is it going to do to get through that intersection, to traverse that street? And what we are left with before version 12 is that the planning side was largely algorithmic or code, what would called a finite state machine, a large body of code. I think Tesla has said was about 300,000 lines of C++ code or something. And this is a large decision tree, right? If this, then do that. If this, then do that. And from my brain, when you think about that, you go, that never ends. That's a very long tail. The scenarios are in the real world and driving. The scenarios that come at you are varied
You
and
cannot code
complex.
for that.
Yeah, it's very hard to build this finite state machine when you don't know. It's finite. There's only so many things that can happen. You don't plan for meteors hitting a car, but you can imagine all the dynamic objects in the space of just a complex intersection, and you're thinking, I'm going to write a piece of code to navigate that. That's a very difficult thing. Moving it into AI is, in some ways magical, and in some ways, well, it's very weird to say. You look back and you say, some ways very obvious, because now you're thinking, okay, what do I do? If you think about this thing I said was code, think of that as a large function. It's like data in. What's the data? Camera data. And what's the output? The output is to actuate controls of the vehicle, accelerator, braking, steering angle. So if you think about that middle part, it's a big function, right? And what the AI has done is replace that function, and it has replaced it by essentially, instead of a human being, computer science oriented, coding that function, you replaced it with data driven. So now what we are doing in AI here is we are using driving data to sort of instruct how that function behaves with new unseen data. So it's altogether obvious now, but I think at the time, when I look back and I kind of see it progress, it was stunning to see that it could be done. And then once once it got there, now I understand it very well to the point where I say, this is probably the only way to do it. And it's the only way to do it to create the outcome that we want. And what is that outcome? And I think it's important to say this. It's not just safety, maybe safety first, but it's also fluidity. It's also the sense of this car drives better than any other person I've ever driven with. That's important for accepting technology, right? It's very important for accepting technology. And so what you have then is the perception with using FSD is that you have this kind of low friction environment. You're not thinking about it driving robotically, because a coded approach is very robotic, and it would never feel smooth and fluid. But if you think about training a system on human driving, and then if you think about selecting only the best driving samples, this is, I think, a very, very key part of all of this. Is it isn't just throwing all the Tesla drivers' data at a system and training a function. No, it's selecting purposefully the best driving scenarios.
What's the term that you use for that? Not cherry picking, but there's a term that you described this with in one of the articles.
I wish I remember the term. Sorry. Yeah, I mean, it's just in simple words. Maybe it'll come to me, but in simple words, it's data selection is very key to the entire fabric of what FSD is, and I think it's not only is it key, but I think it's literally part of their secret sauce. It is what Tesla has, which you would call high quality problem, is they have tons of driving data, more than any other vehicle manufacturer on planet Earth. All the vehicles have been equipped with this, and they're able to move this data to the cloud regularly, systematically. And so that's fantastic, right? You have all the data that's available pretty much every drive mile, but you don't want all that data. You want a very small slice of that, maybe 1%. And now you have to figure out, well, what do I pick? And if you do it right with this model that they picked, in a sense, and this is sort of maybe the profound statement, the car can't drive worse than the best human, because it's effectively told to be, it is literally mimicking that very behavior. And that's, I think, the thing that's misunderstood, is that people continuously say, well, it may do well in these circumstances, but look at this circumstance. And I think to that, I say, well, that's just a function of whether it's been trained on data within that circumstance, right? If the average armchair engineer looks at that and sort of is thinking in their mind, what is the coded approach? Now, they may have never written code in their life, but they're thinking about the logic flow of, well, what does the car do when it encounters this type of thing? And I think, with AI here, we have a very different way we have to think about these things. We have to think of it as, have we just captured data for the circumstance that is questionable, and have we run it through the system and tweak the numbers? And that's it.
Phil, you described the AI as sort of magic, but for me, the magic already occurs sort of one step back. So we are four guys running a podcast, and we also have a studio back in Amsterdam, where you have 3 cameras recording the whole session, and then we collect, let's say, 40 gigabyte on data to render it into a podcast video, and then it takes 2.5 hours to upload that whole thing to the YouTube episode, or let's say 1 hour. I'm always asking, like, how on earth is it possible that a Tesla can have 9 cameras processing something in the milliseconds? Because if you're too late, a millisecond too late, it can have like a deadly accident as a consequence. How are they able to be also on the back end of that so fast with this solution?
Well, I mean, from a data collection point of view, that's a very complex and interesting topic that could go on for a long, many hours. I mean, at Rivian, I built the big data team, so I know what it takes to move vehicle data off of vehicles, store it at rest, and then be able to make it available for use cases, in a sense. If you think about what's happening, 8, 9 cameras, you're collecting frames of data. You are storing that data is stored locally in the flash of the vehicle's ECU, and then there is some decision made when that car comes to rest and comes to your garage and bonds to your Wi-Fi. There is some decision made there which data should be moved to Tesla's cloud, and then when that data arrives, there's a data processing pipeline, and that just simply means that there's a bunch of processes that occur that massage that data and put it in the form at rest that allows the rest of the system accessibility to it in the proper form. Maybe part of that accessibility is selectability. In other words, the idea that you don't want to put data, you don't want to put just raw data in the cloud and then not know what it is. You have to establish a set of metadata that is descriptive of that data, so that you can now select. So imagine that you want to select drive scenarios where you see stop signs, and that's something they want to focus their training on because of some issue. They need to have the system set up so that they can systematically pull data, from what is a vast store of data. So, I mean, I think that FSD, I talk about the compounding advantage that Tesla has, and it's very interesting, and it isn't really, it's a bit of which came first, the chicken or the egg, or you don't even need to assume it is. It's these various things that occur. You have Tesla has this advantage of having the largest amount of data from sensors available in the industry, and as I'm describing, an overwhelming amount, to the point where the car has to assist in the process of determining which data moves to the cloud, because it's too much. It's too much. It's too costly to move that much. And then they, have decided to take an AI approach and an AI approach. And then on top of that, or necessary for that, they have to build an extremely large data center, data processing infrastructure. We think of that in simple terms. We think, oh, that's just a cluster of GPUs, and it's all about data training. But it's more than that, right? It's about storing the data, processing the data, and training becomes, maybe a central focus, or the whole purpose of it. But just holding on to that data and making it available is a mighty big act on its own. So I don't know if I answered your question, but
for me, you did, and maybe it's a good moment for me to also jump in. But I would like to give Kenny maybe also the room to ask a question, because I want to dive into 2 articles of you, Phil. So, Kenny, do you have any other questions you would like to ask?
Just go ahead. I'll jump in.
Okay. So, Phil, thank you for having you. I've been reading all your articles on X. Thank you for writing those. And I was mainly interested to invite you because you are giving actually what you just said, the secret sauce behind what's happening on the AI part, and on the AI part behind FSD, Robotaxi, and the Cybercab. So, and eventually also Optimus. So can you, in short, explain what's the high over idea of the articles that you have been writing about, and what do you want to explain our viewers as well? What's in those articles?
Yeah, I go into 2 different places with my articles. one aspect is to go as deep technically as I possibly can from an outsider looking in. I don't know specific Tesla engineers, and I don't have inside knowledge, and I wouldn't find that to be agreeable, even if I, did on the sly. But it just seems better to look at it from an outsider's point of view and try to tease out the beauty of what they built. So I write articles about the technical aspects, and I guess, and then I write articles about just future states where I see, I try to combine technical focus to future states, and I think, well, what if, my brain just runs this way, what if you have network ubiquity, which means that you have everything connected at all times, whether it's moving around or not? What can you do with that fabric? What can you do with that? What kind of things does that open up? And I think of it in terms of, okay, what does that do for, say, Optimus? What does network ubiquity do for Optimus? What does it do for vehicle and vehicle solutions, whether it's FSD or just other types of things that these modern vehicles do? So I guess you can divide my articles into like pure technical deep dives, where I've done kind of a 3-part series on FSD, and I would say, this wasn't like I planned 3 parts. I might write 4 or 5. It's a bit more like I'm discovering more every day, just like all of us, and I'm seeing something new, and I'm going, oh my God, that's what that means. That's what's going on. Let me think about that more. And so I love that stuff, and it teaches me. I do it sort of for myself because it's just how I think. Like I wrote this article on accelerated computing because I really didn't understand why GPUs were so important. And someone said to me once, "Well, I thought you knew all that," and I'm like, "No, I didn't know it until I wrote it. I mean, I had to research it. I understand the issues of compute and latency and where data has to flow, but I was like, what is in the interior of GPUs that make them so special, and why are they so uniquely suited to solving our current AI problems?" And then similarly with FSD and also looking at Optimus from the outsider's point of view. And then I write about just the future states of like, okay, what can you do with this cool stuff? Like when you combine, I think I try to think, if you can combine these 2 or 3 things together, what can you get? And also, if you do this thing, what does the world look like when it reaches some critical mass? There's an article called Robotaxi Drive-By, and I wrote that because obviously the title is pun worthy, but the idea of the drive-by is it kind of hits you upside your head when you're not looking. It's like, oh my God, what is Robotaxi from say a traditional, simple Wall Street point of view? It's just ride share dynamics. It's just ride share economics. It's nothing more than that from that point of view. But it's so much more. It's something that changes the way humans move and changes the way cities are designed and roadways are designed, and it's a very different state. So I try to predict what that state might be without being too silly. Like I don't want to be so futuristic that it just looks like I don't know. I want it to feel real, and maybe that's because I have my own limits of imagination. I'm not trying to write science fiction. I'm trying to write science fact about what I think future states will be.
Yeah, well, you explained it beautifully, Phil, and I can totally imagine. I mean, we are doing this podcast, and I've been reading your articles, and I thought I understood everything I read until the moment I had to make some questions, and I had to reread everything again. So I completely understand the things, what happens in your head, and that's also one of the reasons that we do this podcast, to explain to others, but also to explain to ourselves while talking.
Yeah.
And that's why I'm very happy that you're here. So I can. One of my goals was to actually do a deep dive into the article that you just touched upon, the Robotaxi drive-by, and I'm very happy you actually explained the title, because I didn't understand that, but by now I do.
I was trying to be overly clever, I think.
Yeah.
Well, that worked.
Maybe you can add something in your next article.
Maybe there's still a little bit of science fiction in you, Phil. So
yeah, I mean that's. Go ahead, please.
No, go ahead, Phil.
Yeah, I was saying that was really fun because I don't know any more than the rest of us. We're just guessing it. We guess at the future. I mean, we can see things that, I mean, look at other technology shifts and think to yourself, did you know? Did you know? A really good example is the iPhone emerged in 2007, and it literally changed everything, right? And we could look back and say, no, it didn't. You see, there were these other phones that were very similar, and Apple just added this touch interface, and you can minimize it if you want, but actually, the best reality is maximizing it to what it really became.
Yeah.
In fact, it's so poorly titled as a phone, iPhone. I mean, that's a good linkage to its past, but probably the least high frequency activity that you do is actually make phone calls with it.
Yeah.
Right. It's really a mobile data device, and multi-touch was one of its key innovations, and the idea that you would just have this nice black piece of glass and the interface would just be completely software defined, and there would be no keys and no little number of buttons. Totally fascinating. And if you look at where we're going with this whole idea of transportation as a service, that is, we're kind of in the flip phone phase of this, where we have these Ubers. Great, interesting. I mean, think about it. Uber, Lyft, great business models. I mean, insane idea of really changing the way to making this transportation available to everyone, everyone outside of the cab oriented approach. And so that it was a good first attempt at a platform connect, and you could see that, and you say, well, okay, what happens when you remove the driver from the equation, and then having done that, okay, what is that? What's the state you're left in? Is it just the fact that you remove the driver, or is there so much more? And that's the kind of approach that I was looking at in that article, whereas like what we're trying to do here is move from, I said, transportation, moving to a state of transportation as a service from transportation as a possession. And I use the word possession quite deliberately, and I wish I could emphasize, it more, because right now most people own vehicles, and my two vehicles, are 30 feet away from me doing absolutely nothing. They're sitting in the garage, and maybe one's charging, but that's about it. So these are possessions I have that I've spent a lot of money on, that largely don't do anything for most of the hours of the day. And if you think about what's the next step with our kids, will they ever drive a vehicle? I doubt it. I mean, what would be the point of that? It would be feeling like we're just upgrading a horse at that point. So, and then that article tries to attempt to say, well, I think when we think of transportation as service, we normally think about moving around a city, right? Because maybe that's where our brains go, because there's a lot of, people density. And okay, so take it from there. I was trying to predict, okay, what would that do to a city if literally 1 out of 3, or maybe 2 out of 3, every vehicles in the city was in fact a cybercab, or some variant of robotaxi in general. But let's just say it's cybercab, the gold driverless cars. What does that do? And then I started to invert that and say, well, if that was the state, why would you, from a city management point of view, allow human-driven vehicles in the first place. I mean, all that does is create the chaos that we see. If you remove, you see certain cities have removed, like they'll change the streets to just be completely pedestrian thoroughfare, and now you have this sort of nice, beautiful landscape, and you can change that landscape. It doesn't have to be um, uh, lanes and stoplights and all the infrastructure that we've put in place. Um, so that's the purpose of that. And I was thinking, what if people just think of transportation as just as almost like a utility? It's simply available. You step out on the street and you just jump in, and you can go anywhere quickly, very, very low friction. I mean, today, people might describe Uber as a low friction platform. I would claim that in the current state, or not its current state, but kind of in a state that we've defined, it seems to be actually high friction, right? We have to wait for these vehicles.
Get canceled.
They get canceled because the drivers have learned to play the system. No matter how many times, I mean, a lot of Uber engineering spends a lot of time trying to figure out how to avoid the drivers playing the system, and drivers have brought to bear. I'm a Lyft driver, I'm an Uber driver. I can use them against each other. They figured it out. And then as a consumer of that service, the other part of the friction is just the driver. I mean, these aren't professionally trained drivers. And in most cases, you might argue the driver doesn't drive as well as you. And so they sort of mindlessly and probably poorly in many cases follow the instructions of the software. They don't know where to go in the city. They don't know the dynamics of
Exactly.
one of the things that I touch upon is that if you consider a good density, and I would say a goal of robotaxi is density, is this idea of availability to if you believe that is true, then all of a sudden, and you believe in network ubiquity, then you know that the fleet itself can operate collectively. And it's sort of like you think of your vehicle as having 8 eyes looking at 360 degrees. Um, and if you think about that, you multiply it by the number of vehicles, now you have forward-looking eyes, and those vehicles can very quickly, dynamically inform the entire fleet within a city, where there's density, where there's issues, where there's problems. And what does that lead to? It leads to safer rides from a personal safety point of view, not necessarily an accident point of view. It leads to more efficient rides, and everyone wins. And that's an interesting future state, right? You think of it as, oh, these are just disconnected objects that work on their own. No, think of them as an interconnected system, where that robotaxi that drove down Third and Market in San Francisco 2 minutes before you is informing your car how to behave. And I think that will clearly come to bear very quickly, actually.
Yeah, you call that the follow me principle, isn't it?
Yeah, that idea, in a narrow sense, the idea there is that that vehicles will sort of follow other vehicles that have created efficient pathways. Uh, so, yeah, generally, I think that it's simply an observation that what I didn't say early on is that my early background is all networking, and so I became fascinated with networks as a young engineer, and when I worked at Apple. In my first go around, I was responsible for the implementation of the network stack in this small device that we made at the time, and networks fascinated me. And when the internet came about, and I saw the explosion of TCP, and just the idea that I knew what was going on there because I've written a TCP stack myself, written that software, And so I've always been fascinated by what you can do with a network that's beyond the capability of the one, right? And if you look at right now, these vehicles are smart devices. In the case of Teslas or Rivians, but they're really kind of endpoints on the network, and they don't really do that. They don't have a high degree of interactivity um, across themselves, and I think um, that's about to change, particularly with robotaxi, because now you can see a use case why you want to do that, right? Um, and that allows all the vehicles to be forward looking for for the purpose of your ride in a single unit.
Hey Phil, if I may pick your brain here a little bit as well. So I think looking at the case and the future state, super interesting, and I think more things will change. So for example, in Europe, we go a lot by train and by plane to other places in Europe. Last time I stepped in the car to go to the south of Europe, I said to my girlfriend, next time it's in a robotaxi and you go by night. So I think can change a lot of dynamics other than the city as well. But what I would love to get a better feeling of from your side and also have your view on it is more on the software piece. So I'm not a software engineer. I've done quite a bit in tech, but it's all finance related. So still not really a feeling. But if I look at the business case of Tesla and really executing on what they say they want to execute on, I have less of a feel with the software part. So I think on the production side of things, they've really shown that they can innovate, they can produce high volume robotaxis or cars, because they're basically, let's say, the same platform. And in the future, also the humanoids. But from a software point of view, like how close are we to get to full self-drive and get to capabilities for humanoids as well? Can you maybe shine some light on that part?
Sure. I think, going back to an earlier discussion we had, is that I think in the case of full self-drive, this idea that we've gone end to end with AI is leading to what I call the convergence point. This is a piece of technology that's uniquely different than others, and in that you release it in the approach. It's sort of like in the approach to convergence, in that convergence means it has solved the problem. It is a solution, and what's left is a very, very small tail at that point of things that will increasingly be improved. And so we are seeing that happen. And I think with FSD, we are merely compute bound at this point. And what I mean by that is that um, because we know that here's what we can observe. We can observe that this big box of magic numbers, the neural network, um, in its current state or potentially version 14 state. And what I mean by that is, the current model is about 1.5 billion parameters. It's a sum total of its weights and biases. And so really what you're left with is you're left with a model of the architecture of the neural net and its numbers when it works on the car. Okay. And so version 13 has about 1.5 billion parameters, and let's say version 14 maybe 3 to 5x that in size. And now what we're doing here is we're simply nudging these parameters. The parameters are numbers. Okay, they're numbers. Nudging these numbers to some level of trained perfection. And so what I see it is a problem of it's compute bound. And simply what that means is we need to train it on the most amount of data for unseen circumstances, so that it can process new unseen circumstances, our drives. Um, and so it is a compute bound problem. In other words, it reaches that point of convergence. It reaches the solution purely based on that. It's not limited by other types of things. And people may say, okay, I'm sorry, you're wrong. In a heavy rain, this system can't perform. And there may be some very small number of cases where that is a true statement. And then, But then the question is, what do you do here from with this architecture in heavy rain? Well, you train it on heavy rain. You train you cherry pick driving scenarios that are heavy rain. You cherry pick driving scenarios where the left front camera is occluded or with mud or some other debris. That's what you do in this type of model. So I think the theme here is that we are really left with a compute bound problem. And what that largely means is we have to process a lot of data, and we are compute bound, which means that if we try to train a model like version 13, Tesla has this incredibly large um, data center Cortex on the head of the
Austin.
Gigafactory in Austin, and it's an amazing facility, and it's maybe 50,000, 100,000 GPUs, and if you think of it as 100,000 GPUs of some flavor from NVIDIA, it version 13 took a certain amount of time to train that model, and let's say we can count it in a number of weeks, and let's say it's roughly 8 weeks, like 2 months worth. What if 14, all else held equal, if 14 is 10x the number of parameters? It probably won't be, but if it was, it would largely take 10x the amount of time. So 2 months would shift to 20 months, and that's untenable, right? That's not, so it's compute bound. It means, okay, what do we need to do now? We need to 10x the compute to get back to a constant training time of some constant training time. Again, all else held equal, there's some differences here, and the differences are more data to train on too. Not just repeating the old training set that we did on 13, but adding to it, and we're shrinking the tail, or we call it the March of Nines. We're compressing this down, and we have a tail of smaller and smaller unknown scenarios and driving that ultimately become, they're a long tail. This is a creature with potentially the longest tail of any that I can think of from a computer science point of view. But there's a point where you've reached, that tail is very, very narrow at the end, and we're just kind of
And low probability cases as well.
yeah. I mean, there will be cases that Tesla sees these. That's, again, I come back to this idea that data selection is key.
Mm-hmm.
And what is Tesla picking for training scenarios? I mean, we often think it's interventions. Well, frankly, most of the interventions in, say, version 13 today are just people wanting to break the route and go a different direction, or take control of their vehicle. It's not usually because the car is about to hit an obstacle or something. That's not what's happening.
And not safety or performance related.
They're not really. They're really about control, vehicle control, and frankly, once we get a voice interface in the car, then that what we have is, the reason we control a car is that we have a very low latency from our own photons in our own, to controlling that vehicle. That's why we have vehicle controls. So we have very, very low latency. I mean, humans have higher latency than the car's inference. But that said, the reason we have controls is so we can do that. Now, if you're using FSD and you're navigating to a particular location and you need to change the navigation, you can't do that instantaneously, right? It takes some time, and so you create this intervention, and you think, oh, that must be the moment in time that Tesla is only gathering data. No, I mean, what's happening in our Tesla vehicles is that they are continuously, when FSD is not engaged, they're running FSD inference constantly.
Yeah, shadow mode.
Yeah, it's a shadow mode, and that approach allows them to do some differencing between the human decision state that was made and the vehicle's state, and then say that's a box of potentially selected data, and then another box of data is interventions, and another box of data may be just something that they instructed to do. For example, they might say, we are very interested in all driving data through school zones. And so we don't know how this is happening, but I'm certain it is. Let's instruct our fleet to collect data through school zones, because that's what we're going to focus some level of training on, because they saw something in the field that they were not happy with, and they wanted to bring more data to that. And then, of course, you asked sort of about software in general. Optimus is really another software-defined architecture. It's very exciting to think about Optimus. I haven't done as much deep dive into how the AI is done there. I feel like it's similar to FSD and also incredibly different. Because it has, if you just think about Optimus, a car has really very limited number of controllable outputs. It has the brake pedal, which is really, a state like how depressed, how much brake do you put on from 0 to 1, something like that. You have accelerator pedal, similar, where 0 would be no accelerator, 1 would be 100%, and 0.5 would be, 50%. And then you have steering angle. And that's largely it from a controls point of view, right? If you look at Optimus and you have these, you have the hands, and if you look at every single,
it's basically 360 degrees. It's like all dexterity in all directions.
It has, if you just sort of compare its output state to what I just said for a vehicle, it's much larger. You had 22 degree of freedom hand. You've got 2 of them. You've got shoulder movements. You've got elbow movements. You've got hips. You've got the sort of knee to foot and the movement there. The head angling for where it's essentially looking like we do. So, it's a much larger state of larger control surface. And so, and then the training is different as well, because, is it simply supervised learning like we do with FSD? No, it's probably more like reinforced learning, which is a sort of a different way of approaching the problem, where you're sort of mimicking a human is asked to perform a task, and
it's the same for movie industry, like motion capture, right? Kind of.
Yeah. The idea that you would kind of follow that task and how the human solves it, and repetitively, and then the key is to generalize it, right? Because you don't want to be directly precise. You need some level of I'm going to say the word inference, but you get the idea. So yeah, I think FSD and Optimus share a core, and one thing is they share the knowledge set of the team. The Tesla's AI team, which is quite an advanced team.
Phil, before we go deeper into the Optimus robots and capabilities, what we see there, I'm very curious what your thoughts will be around the rollout of the Cybercabs. We're working towards this June moment where Elon announced the Cybercabs will be available in Austin. And I'm also very fascinated by the idea of your networking, sort of be all the cars being connected and also being forward looking. I almost have the imaginary of thousands of worker bees are now helping robot car worker bees are helping humanity in transporting things, just like worker bees do for their hive. What we know is that there will be a car coming off the production line every 5 seconds when it's in the optimal stage, which is a sort of insane statement on its own, seeing how difficult manufacturing is. But probably the rollout of getting to volumes will be, let's say, if I'm like super optimistic, it will be maybe 500,000 to 1 million Cybercabs in 26, 27-ish. So do you think there will be a focus of Tesla on sort of high use case scenarios like transport from airports to city centers? So sort of selected areas and selected routes in the first phase?
Well, I think if we back out sort of at the higher level, I think I did some computation. It could possibly regurgitate it, but I think it came down to this: is that if we tried to penetrate about 10% of the miles driven every year in the United States, which is I think 3.2 something trillion miles, and we move those onto the Robotaxi platform, we need about 3 million units operating in the United States to get 10%. Okay. So, there's some estimated duty cycle, maybe 200 miles a day or something like that. 3 million units is the reason why Tesla is aligning its manufacturing to this 5-second insanity. I mean, if you think about it, I think that the key success factors here are, let's define terms a little bit. Robotaxi is the overall network for transportation as a service, and in that fleet would include the purpose-built car, Cybercab, ultimately the purpose-built larger capacity format, Robo van, and then the various Model Ys, Model 3s, possibly X's and X vehicles with probably level hardware 4 or greater for joining that fleet, right? And a large portion of those cars will be customer owned. The assumption is that customers will be able to check their cars into service during idle times. So I think that if you look at, if we kind of focus a little bit more on Cybercab itself as the purpose-built vehicle, here we have a vehicle that has no driver controls, but what's really the magic of this vehicle is sort of its design, and its design is to be built at high volume at the lowest possible cost, and why? Because we need a lot of them. We need a lot of them. And I think the service as a whole, availability, which is basically your wait time in another way of stating it, needs to be as limited as possible. So then we kind of look at the Austin trial, and I think there's a lot of questions there as to what that is. And I think that I take a much more narrow view than most, maybe. I think it is a series of Model 3s and Model Ys that will be put into service. There'll only be Tesla-owned vehicles, and they'll have a limited geofenced area through which they accept rides. They'll release the rideshare app, probably as a separate, distinct app in the App Store and the Google platform as well. And then individuals will be able to take those rides in that geofenced area. And I think that's possibly the scope of what we'll see in Austin. And of course, that the second they see some level of success, scale can occur. And what does scale mean? It means adding more vehicles. It means increasing the geofence. And then ultimately, it means other cities, in the U.S. with regulatory approval. So I think the goal, I think, of Austin is narrow but defining, and that once we will have proven that. I mean, think about what we will have here if it works well. We'll have unsupervised FSD in the wild. I mean, that's pretty
wild.
It is wild. I mean, it's a bit hard to believe, I mean, it isn't hard to believe for someone who's done 4,000 miles on FSD 12 and 13 myself. But it is hard to believe that an individual who has never been in one of these vehicles will be able to jump in and go from A to B.
Hey, and
Well,
Phil,
we're still riding horses in Europe, so
yeah, but
talking
Phil,
about unbelievable.
Phil, I'm curious because you seem quite certain that version 14 will be the version that's going to be unsupervised, and then that it's going to be uh, unveiled at the Robotaxi event. So, like, my first question
Yeah.
is, how certain are you that that's actually the case or going to be the case? And the second question would be, would V14 become available for consumers like that are having FSD supervised right now, or will
Yeah.
it stay limited for a while to, let's say, only the commercial cybercabs?
Those are very good questions, of which I only have theoretical answers to. I mean, I think, look, here's what we know. Version 13 has been out since, I believe, late last year. It's gone through about 5 releases, if I remember my releases. I think we're on to 13.2.8 as a present release, and we haven't seen anything in quite some time. And what that indicates to me is that Tesla is very, very busy internally, and they're focused on now they're focused on the unsupervised aspects of robotaxi, which, believe me, is not just a straight line. I mean, it's like there's a lot of little loose ends here that they have to deal with, and in terms of taking a rider in a vehicle and moving that rider from point A to point B.
Yeah, entering
And
underground garages, gated
there's a lot
communities. Yeah,
there's a lot of things here, and I don't know how many things, but it makes sense to me logically that this unsupervised is a new whole version, meaning a version 14. And what would that mean? I mean, largely what that means is it's a new trained model, has more parameters, um, and of course, it probably a lot of the training data is focused on some of these unsupervised scenarios, or I should say, ride share scenarios specifically. That's a better way of saying it. And So, yeah, I think that's what what we'll see, and I think what 14 will be is a bit of a superset. I'm guessing it will have an unsupervised mode, um, which means that it will be able to do this trial and anything that they start moving, as they expand the trial. And I also think it'll then end up on the consumer vehicles. And in the beginning, it will probably run in supervised mode because we don't have the approval to run our own individual cars unsupervised yet. Um, and so it will probably, have the same set of supervised features on top of it, which is, essentially
Yeah.
driver monitoring, kinds of somewhat
Phil,
annoying.
we have been seeing Tesla, of course, publishing videos where the cars drive themselves to their parking lots for shipment, and so they're making a lot of miles already
Yeah.
with no drivers in them. Are we also going to see sort of driverless cars in Austin, where they're just roaming around with nobody in them, and then how will that work from a sort of insurance point of view?
Yeah, I don't know how it would work from a liability or insurance point of view, but I suspect that you would, at least from there'll be a network of cars that they put into this trial that they'll you know that they have produced, probably Model Ys, Model 3s. I would suspect that at any time those cars are not actually moving passengers, that they won't generally sit idle. They'll just run phantom, like almost like shadow mode today. They'll probably pretend that they're picking up a passenger at some stop and dropping them off at some other random stop so that they can exercise the system at large. So I think, you'll see that phantom mode as well, or that shadow mode as well. Yeah, because I mean, what is the key? The key here is that this is in fact a trial, and it it will have a lot of the earmarks of being a trial. It will have probably a limited availability, a limited number. It's not. I don't think they're going to release the app and say, "Everybody, here you go." I suspect that they'll ask people to, invite. They'll be invited into the trial. There'll be a certain limited number of
Similar to
passengers.
the OG testers, kind of, right?
Yeah, people have accepted some limited liability kind of thing or something,
Signed
and then and then you're good to go, and ultimately they'll drop that wall and just make it generally available. But this isn't here. I'm not here to predict the velocity that they go into scale. We're talking about the pre-scale trial mode, and I'm being very limited into what I think that trial attempts to accomplish in the early.
So you talked about the Uber model, and since you're a software guy, Elon talked about in one of his last earnings calls about the ride-hailing network already being active among employees in California. Are you aware of any of what is happening there, and any thoughts on how that ride-hailing network will look like? Will it be more sort of Airbnb or more sort of a Uber where Elon talks about?
Well, I mean, I think, the good news for the team that's working on the ride hailing component is that they've had a lot of time to do it. And what I mean by that is they've essentially been waiting on FSD, right? I mean, if you think about what are we waiting on? We're largely waiting on FSD. I mean, you could say we're waiting on Cybercab production as well, but that's not necessary in the short term. The short term, we'll be using Model 3s, Model Ys. These are capable cars to run FSD. So we're waiting on the version of FSD that does the unsupervised things, whether it's a 13 dot release or it's a 14 release. I suspect it's 14. Now you have distinct from that, I mean, interwoven as the service, but distinct from that, you've got the rideshare app itself. And what does that mean? It's think of it as like the Uber app, in that it's designed to see the availability in the network and match a rider with a vehicle, and bring that vehicle to the rider's start point, and then confer the destination to the vehicle so that the vehicle can not only make its way to the destination, but have a user interface exposed. So I think that, not only does a little bit different with the Tesla vehicles than, say, an Uber ride, is that today in an Uber ride, when you're an Uber, you can stare at the ride on your own application, and you can see how you're progressing towards your destination. But I think you'll also see that mirrored on the vehicle display inside, certainly in Cybercab, right? Because we have this large display, and one of the main functions will be displaying our destination and the time to destination, and that type of driver info, and then the ability possibly to control it outside of voice, different types of things. But I think that the rideshare network, which is a server-based system with a front-end application on a mobile phone, has been in development for a very long time. And the thing is that you can exercise that without needing FSD, right? You can completely exercise that. You can call a vehicle. In the early days, they might just drive the vehicle to the start point. Today, they're probably, what's happening is employees are sitting behind the wheel. They're running it in supervised mode, and they're exercising the network for another employee to take a ride. So when that car shows up, there's an employee at the wheel, there's an employee wanting to take the ride, and the two are, they're different functions.
They're doing that in Berlin already, I think, with some test drives around Germany and the Netherlands.
Yeah, I suspect that, you think about, if you think about FSD, just in a narrow sense of FSD itself, FSD, when a model is in the data center produces the model. Like, this is it. We've got the minimal, what we call minimal loss in the function. We see this as a potentially candidate release model. What's going to happen next is they're going to take and run a test, a set of test data through that model, and they're going to score that. They probably have a multi-tiered scoring system from aspects of safety and other performance variants, like dynamic ride type of things. And so they come up with a score. And I would tell you that probably now that score is enough to be certain that they could almost release that model to the public almost instantly, because they've essentially run real drive. I mean, think about it. At some level, they've run real driving scenarios through the system. There's not a lot that has to be done from a last step validation. They probably load that model onto a series of cars, and employees drive them around through a set of test scenarios, and sort of, check the box. This is a releasable version. But I suspect that that last piece is getting to be smaller and smaller, and most of that test is, you think about it. If you trained on, say 200 billion driving samples or 300 billion driving samples, they probably have another couple 100 million validation samples that they use. And then so they have a block of those, right? And they run them through the model. Let's say they have a 1328, and then they try to fix something and they call it 1329. And here's what they're trying to do. They're trying to validate that the thing that they fixed is fixed in 13.
Is that the reason why those cars, like the fleet validation vehicles we see driving around with LiDAR and stuff, are those used for validating, or is that purely like a synthetical simulation of it?
Yeah, well, I think when you see it, so that's when you see a Tesla vehicle aligned with LiDAR. So if you go back in history a bit with FSD, LiDAR was used as a calibration element to essentially create ground truth for the spatial. So what is the vision system is meant to replace the LiDAR system wholly.
Yeah.
With this idea of that it can do spatial awareness through frame differentiation, right? Basically. And so it can detect moving and non-moving objects purely through the set of pixels that it's presented. It used LiDAR to essentially help train that system. So the best way for me to describe
check
that is
if the distance perception, the probability, like if that was a correct prediction or estimate.
Yeah, I mean, or just to create, to say, okay, did you you see that box in the roadway? How from the vision system's point of view, how many centimeters away from this camera do you think that is?
Yeah.
And then in the next frame, how many centimeters is away? Oh, it was 250, and now it's 249. Is the car moving or is the box moving? If you think about it, I think LiDAR is sort of like, if you've ever played piano and your instructor labels the keys on the piano, what do you know about that? Before you learn with labeled keys, but then when you go to perform for anyone, you take all the labels off, and now it's just your hands, right? So I think LiDAR functions like that, or maybe another analogy would be like training wheels on a bicycle. You learn how to ride a bicycle with training wheels, and then when you want to go into production, you remove the training wheels and you never put them back. So I think we're seeing I think LiDAR is being used less and less by Tesla for any of this validation. And I think where you see it today, they may be testing very new systems. Like maybe they have a different way that they've oriented a neural network to do this spatial awareness through video, and they're kind of going back to using LiDAR to validate this system. So, a lot of times when you're in a development organization, you often think to yourself, oh, I mean, you're looking from the outside in, you think everything is about one thing. but that's not true. There may be a team that's working on a futures idea of some kind of spatial awareness thing, that some algorithm they're testing, and so they go and they say, okay, well, let's go hoist up that LiDAR system, and then you see it run down the road, and everybody's like, oh my God, Tesla's doing LiDAR for. And it's like, you don't know what they're doing it for. They're probably doing it for this.
For instance, for that occupancy thing that they introduced like a couple of years ago, where they would mimic like LiDAR behavior, that they would see an occupant area behind a parked vehicle. And then they would like run a fleet validation vehicle to actually establish if that was actually the case. And then if once it's confirmed, they can build upon it, right? That's more of the logic behind it.
Yeah, I mean, but they also have, usually source video where a human can inspect the source video as well to create. It's just, LiDAR, a lot's been said about LiDAR. Unfortunately, the reality is if you were going to augment the FSD stack in the vehicle with another sensor, I would pick radar, not LiDAR, because the principle, often people say, well, this is how a Tesla would perform, and this is how Tesla on cameras might perform in rain, snow, or fog. But LiDAR doesn't solve that problem. LiDAR emits light. Therefore, any object in the air, whether it's a particle of some moisture particle, whether it's rain or snow or fog, it scatter. You get scatter. So that's not the right solution. But what LiDAR will do is it will create a in a pristine environment, and even sun saturated. Like if the camera is saturated with a lot of sunlight, which is in a different spectrum, the LiDAR can be somewhat blinded. They have techniques now to sort that out. But so LiDAR doesn't solve that problem. But what LiDAR is going to do for you is create precise measurement. And so what is Tesla attempting to do? Is trying to factor it out, pull it out, and say, well, we can do close to precise measurement through this frame differencing on the camera. So we can not only detect static objects and the distance that our unit, like the center point of the car, is away from that static object, but we can also tell whether that object is moving, and ultimately through the perception part of the AI, we can identify the object as well, right? So we label that object as, oh, that's a human being, that's a canine, that's a cat, that's a that's a box, that's a stop sign.
Put meaning behind it,
yeah. We have to, for if you look at a scene, if you just see a car and it's approaching an intersection, you take one simple frame. Now imagine if you walked through that and you labeled everything in that frame. I mean, you labeled the lane lines, you labeled the separators, you labeled the signage, you labeled the pedestrians, you labeled the other vehicles. Yeah, and what you're going to want to do with that is you're also going to want to assign other attributes. What is their position? Even if are they fixed or are they moving? In other words, create a vector for them. Like vector is direction and speed, and it could be, well, it has no direction, it has no speed, meaning it's a fixed object, or it's an object that's coming through the intersection at 30 meters a second or something. And then you might also label it with intent. The idea of what the system predicts its next piece of behavior will be.
Very important.
Yeah, super important. So, for example, you have a pedestrian, and you want to say, well, is that pedestrian just hanging out at the side of the road, or did they have an intention to cross the roadway? And you can get magically better at that. One of the things that I had said in one of the articles is I said, okay, imagine you take Cybercab. It was in the drive-by article. I said, imagine you take Cybercab and you throw it into a city center, and now you have a lot of them, and they're networked. And so one of the things you can do is you can do this idea of dynamic geofencing. And when I say dynamic, I mean literally dynamic, not something that's like day old type of thing, but maybe minutes. And you could do things like, okay, I don't want to head down the street because there's, an event at the large arena has ended and people are flooding the street. And so maybe the routing system thought, well, that's the best way is take the river route right by the stadium. Well, not when people are exiting, right? That creates a great degree of density, and then the traffic slows. But if you get really good at this, so any one of you can probably, using your own intuition, you probably don't necessarily process how you're doing it, but you can look across the road and look at someone, and you can sort of say that person is benign or dangerous to me. And what so next time you do that, think about why did you draw that conclusion, and you've done some type of profiling, and whatever that is, whether it's socially acceptable profiling or not, that's what you're doing. You're doing it at all times. You can believe that the vehicle, through its perception model, can do that as well. So it can say, oh, I see people congregating in an aspect that looks like they're dealing drugs on 3rd and Market. So I'm going to geofence that area off right now and not allow other cybercabs to go down there, because those people are unpredictable in their behavior. Or I see some kind of protest, showing up in an area. I see the people congregating with a purpose that looks like it's going to lead to that. You have a lot of situations here where the anarchy of California, we've had circumstances where roads are blocked off by these protests that just show up, and it's very scary for someone that's driving to approach it, because what is that? The person's thinking multiple things, like, well, I can't hit another human being, but I don't know what kind of danger they're presenting to me and potentially my loved ones in the vehicle. So they're in a very uncomfortable position, and sometimes people just sort of drive on and then face the consequences of whether the law is going to prosecute them for hitting someone or whatever. The point I'm trying to make is, imagine Cybercab just factoring that out of the equation with real-time data, to eliminate that from a congestion and safety point of view.
Yeah, it's amazing. It will become like a data sensor for all other cybercabs. And
absolutely,
just putting the information through to everybody. Yeah. So,
and frankly, go one step further and think of it as it's a data sensor, meaning maybe for Tesla, it's a data sensor for the purpose of creating safe and efficient rides, but it's also a data sensor. So therefore, the data itself is highly useful for lots of different activities. You can imagine city planners looking at some kind of aggregation of that data and determining. I mean, we have cameras that are set up at intersections just to count vehicle flow. We have a lot of silly external infrastructure that's off vehicle to do silly things that the vehicles are perfectly capable of doing from a data collection point of view right now, right? It's just a matter of, if you think about in my particular area, the density of Tesla vehicles is extremely high. It's probably, I don't know, maybe the highest in any particular area. I mean, my neighbors, I would say 1 out of 4 cars is a Tesla here. That's unusually high. If I go back to other parts of the country, 1 out of 100, 200 cars sometimes, but when you look at Cybercab, it's a whole different equation. As it starts to flood into these high density urban environments, now you're going to see a lot of those vehicles. And so then all of a sudden, they are data sensors with a lot, not just coverage in the complete sense of, but coverage based on a time unit as well. So if you want to see this roadway at this hour of the day, I think we did this at Rivian. We had some pretty incredible software that mapped out where our vehicles went in the fleet. And I'm talking about engineering, employee, customer. And we weren't tracking individual vehicles, but we were able to create a good sense of where our vehicles are used. And frankly, not only can Tesla, I might argue that today Tesla vehicles are collecting data, and there's probably some project where they're analyzing every make and model of every vehicle on the roadways in areas. So they say, well, in Tucson, here's our competition, but here's what it looks like in Phoenix. Here's what it looks like in Denver. Why not, right?
Yeah, that must be the case, because before they created the Cybercab, it's a two-person car, because they know exactly how many people are inside of the car on any given ride. So that whole, if you think about how much data a fleet of, let's say, 7 million car-ish at the point we are right now will be, but if you compare that to 30 to 40 million cars, that's going to be that's going to give insights we never had before in, let's say, managing traffic, but also society.
Yeah, I mean, it's the power of the data is quite extraordinary. It not only shows you a view of ground truth, but it shows you a view of the future. It's a predictable engine. I mean, after all, that's what FSD sort of is, right? So if you look at, we had projects on my futures team at Rivian, without spilling any, where we could create a neural network where we could do some kind of predictive density where we would see the most charging of Rivian vehicles. And we were trying to minimize the inputs to, is the vehicle moving? What direction is it heading? We could care less if it was on a road, just directionally where it was heading, at what speed it was heading, and what was its state of charge. And given those factors, we were trying to determine intent. And what intent would be was, is this person heading towards a place to charge their vehicle, or are they just heading to some destination point? And we found that with greater than 80-something% certainty, we knew when a person was, we had these time scales where 15 minutes out, 30 minutes out, 45 minutes out, hour out, what we would predict when the vehicle would have the intention to charge without anyone telling us a thing. We just look at the data and literally like 5 data elements and come up with about, I don't know the numbers, but about 85% certainty that we would know when a vehicle was heading to charge. And that's just one thing, right?
Yeah.
But this is exactly your point you made at the beginning of this podcast, that it's not just some ride-hail network, but it's a data collecting, and with the data you can bring up multiple kind of business models. And also you also write it down in that article about the hyper-connected car, where you actually say that with the data that actually the cars are getting, they are able to create like a process that you call perception. It's like that the vehicles can operate like an aggregate.
Yeah.
So that for me was a very interesting kind of way of looking at it. Maybe you can explain a little bit about that.
One of the things I said in that article was, I said, imagine that, one of the things that you often, I took a small scenario that we all experience this continuously, right? We're driving down the road, we're on a highway, we're going to a destination, and the road shuts down, right? It's like goes from whatever miles per hour, kilometers an hour, down to 0. And we ask this fundamental question in our brain: what's going on? Is this a small aberration, or is there a major blocking accident on the roadway? And then we start trying to collect data to figure this out, right? We start looking, we zoom our, I guarantee all of us have pinched our maps up and down to try to figure out where's the red zone of the road. And oh, look at that. It went from red to back to blue or green, whatever good state.
Always.
Right after that, oh, and we infer in our brains, we're like, oh, it must be the road is shut down. Oh, we see some emergency crew, running down our shoulder towards this. Okay, probably that is confirmation, right, of this. And then we decide, what are we trying to decide? Do we get off the road or we stay on the road?
Yeah.
Right.
Mm-hmm.
And because we know, all of a sudden the predictive thing that told us that it was 30 minutes to our destination is now meaningless, because it now just crept up to 40, and we're sitting there and now it's up to 50. And we're like, okay, if the road shut down, it's infinity is the real answer, right? So in that article, I said, well, what if we had sort of a drone or something? We could just fly the drone forward and inspect the road. And in a sense, what is that drone? That drone is the other vehicles. I mean, they're there. They've come through that space before us. If they're part of a interconnected network, and we have AI now that is so incredibly amazing from a generative point of view that we can reconstruct a bird's eye view of that highway in real time with enough data collection. So we have, old data that tells us what it looks like. Kind of think of it as like the Google Maps view of data, where it's like, okay, we see the satellite view and we know that, oh, that looks like it's sort of representative, but geez, that building, there's a building there now, and the overviewed, right? So we go, oh, I guess that's satellite view, and we see that like weird things where, oh, it's a sharp line, and because there's new tiles, map tiles that have, and so imagine that you could take a fixed sense of that overview and then generatively add, and you could almost have a dynamic real-time view of the road ahead. And that'll be true certainly in cities as well. And instead of pinching and looking at this red segment, you could pinch and look at, oh, I see emergency vehicles, and the perception. We're not in a state now where it's the human has to tell us something, but rather the AI itself. I mean, we look at the FSD perception and we think, why are we perceiving this environment? Well, perceiving this environment so that we can drive the car autonomously. But then there are these other use cases that say, well, if we're perceiving this environment, that's a higher level, that's a higher level kind of construct of what it is we're seeing, and so we can then create intent. And so, like the example is, we often see that the new state of the art thing is a fire truck will come on scene and it will like create a block, so that the emergency personnel can stand behind it and clear an accident, right? And just its position across the highway diagonally or horizontally kind of indicates what the heck's going on. When you see the firefighters, emergency personnel start to come back towards their vehicles and the vehicle starts to move, you get the idea that the road's clearing, right? And you can see that if you're close enough, but what if you're 2 miles behind? You have no visibility. So that data is incredibly powerful, and it's even more powerful now because we can use the perception engines, and in this case, I'm kind of speaking specifically about Tesla's perception engine, to infer meaning or create metadata on top of the raw data, and then get valuable information from it. So yeah, pretty interesting.
Yeah, you also explained in that article that in the future, if this is all possible, this is already possible, that eventually all road infra could be dismantled because the cars are already in connection with each other. Combine that with LLMs, and they are actually combined and connected with voice. So you don't need the infrastructure anymore to communicate between the cars.
No, and the infrastructure is built for
Which
humans.
we made it very clear what you just said. It was, oh yeah, the cars are the network and they communicate with each other.
Yeah.
And they have enough data to.
So when I first started at Rivian, there was a lot of talk about this space called V2X, vehicle to infrastructure, and there was a supposed called pipe dream, government pipe dreaming ideas of we're going to take our roadway sensors and we're going to equip some of the infrastructure with sensors and most of them for output and some of them for input, and so we could dynamically change traffic lights and as cars are approaching and all this is incredibly possible, but the truth is that I think at that time we saw that problem and thought, or at least I thought, bullshit. Like that's not the way the thing is going to evolve. The way the thing is going to evolve is that private enterprise through companies like FSD, companies like Tesla, companies through Rivian are going to use their own fleet as interconnected sensors to do the things they do, because the lag time for governments to provide solutions like this, the only thing the government can really do in this case is it can lag behind and then it can create blockage, right? It can say, okay, you can't do this autonomy thing because you need to do this thing. And the way Tesla approached it is, okay, let me put it a different way. If you were to design from the get-go, from the start, you create a brand new highway and you had an autonomous vehicle, would you design the highway the same way that you do today? Of course not, right? You wouldn't need any signs. A vehicle, autonomous vehicles could easily travel at very high speeds with great density with no possibility of collision because they're all seeing each other and talking to
Only if
each other.
there's no humans around them. Yeah.
Yeah, only if there's no humans. So what we're doing is we're basically, 80 or 90%, maybe way into the 90% level of Tesla's solution relates to the fact that there's humans driving cars around it. So, I mean, autonomy is easy, not easy, but it's easier by a great degree if there's no other non-autonomous.
Yeah, the transition phase is the difficult thing.
Yeah, I mean, we don't have uniformity, right? I mean, you could make the argument that another vehicle is running autonomously with a human robot driving it. Let's just state it that way. But there's an unpredictability to that fleet that's different than, say, there's a high degree of once you transfer the model to the vehicle, the model is essentially read-only. So the behavior of my vehicle and another vehicle with the same conditions is 100% identical. But all four of us would drive differently. Our decision frameworks would be, they're all aligned towards some of the same goals, but they're some of us inject more emotion into our framework of this. The clever way of saying something. Some of us
road rage.
Yeah, road rage. Some of us drive aggressively, some of us drive conservatively. All of that. So, if you go back to part of the discussion we had early on, was I said that one of the biggest things that Tesla did was they selected the right data, right? And the right data, and that's sort of the art. There's a lot of art in that.
How did they do that? Because that's actually the difficult thing. They started out with these safety scores, and like that might of course be something. But how do you select the best drivers? Which parameters would you select to be able to get the best drivers out of that fleet?
So when you train a model, in the scope of AI, machine learning, and these deep neural networks, when you train a model, you one of the magical elements is called the loss function. And the loss function tells you the delta between what an unseen piece of data has in this network and the predictability. And let's give you a simple example. Like if you were if you had a handwriting sample and you trained a neural net to recognize the numbers 0 through 9, and the outputs of that were just 10 boxes, 0, 1, 2, 3, 4, and there's a probability, and the probabilities add to 1, right? So you write a 5, right? You write a 7, and let's say you write that 7, and the 7 box says that it's 97% .97 chance that that's a 7, and then for some reason the 5 box has 0.03, and the rest have 0. So what do you conclude? You conclude with some degree of certainty that that thing is in fact a 7, right? Well, there's also a function in there that's very important called loss, and when you're training a neural network, you're trying to minimize loss. So your training set in these things is largely called supervised, which means that you when you take a piece of driving data and you input it, you already know you've labeled the output. So the training set is aligned towards these well-known outcomes of certainty of what you're trying to achieve, like standoff distance, like you have 100,000 samples of driving data, right? And there's a car, and what you're trying to do is you're trying to determine the car in front of you stops. Maybe it stops short, maybe it just kind of is coming to a stop, but you're trying to, what are you trying to do? You're trying to actuate the controls on the autonomous vehicle behind it to come to a safe, standoff distance. Not necessarily stop the vehicle, but just, if this car is traveling at 100 kilometers an hour and you're traveling at 125, you're going to hit that car in a certain number of meters. So what you're trying to do there is, okay, I want to slow my car down. Well, what does it mean to slow this car down? Well, it means add brake or remove accelerator, right? Because then you have some regenerative and then just general,
it can be one or two.
Yeah. So let's just say it's brake. You're adding brake and keep it simple. And so the question is how much. And if you can train with samples that properly create that standoff distance, then you can say, okay, this is a known training set, and this set is good, right? What are we going to discard? We will discard the training samples that ran into the car in front of us, right? We'll also discard. Yeah, we'll also discard the training samples where the driver applied a heavy brake and never came even close to that car.
Yeah,
right, because that's just ridiculous too.
He's too conservative. So you need to have that fine spot.
Yeah, I call it the Goldilocks principle, right?
That was the one. That was the one that I needed at the beginning of the episode. Yeah,
that was the technical term. But yeah, I mean that's the goal, right? The goal is to get those proper safety high on the list, but also smoothness, fluidity, and you get those proper ones, and you say, okay, if I train with that data, then with new unseen data, how can the car perform different? It can't. And that's the beauty of FSD. That's why I say it's converging. That's why I say it's going to be a solution to full autonomy, because it can't do worse than that data. It can only do poorly if you train it with poor data.
Yeah, but it learned from the best drivers, so it'll reach that base level. Hey,
right.
Phil, I think we could go on for at least if I speak for myself, I could go on for hours and hours and hours. But
Phil needs a cup of coffee as well.
Definitely.
Yeah. Grab my 5th espresso of the day.
Hey, but I think we could easily do 2 more episodes discussing another FSD episode, but I think Tesla Bot deserves a whole another episode dedicated to Tesla Optimus as well.
Yeah, he's an interesting product, to say the least.
Definitely, yeah, it is, and
so many questions about that I love to address in the future episode. So you talked about the use of sensors. Well, a human has a whole bunch of sensors in their body, right? So wonder how that will transfer to Optimus. But since it's so worthy and life changing, we will we would love to dedicate some future time on that.
That's awesome. There's one really good article that I wrote. I think it's called
the Tesla Optimus network.
There's another one called I Can See or something. Tesla. I forget what I called it.
The next big thing.
It was I Can See or something, and it was what the idea behind it was. I was taking the idea that this bot with its sensors can see the world, and what does it mean to see the world, and what things can it do? And we can talk about this in a future episode, but to tease it, you can do things that are extraordinary with something that is a seeing, and then you have this network effect. And that article, it sounded, when I wrote it, it was almost, it felt a little insane to write, that kind of ideas and throw them out there. And then it gets reposted by Elon.
Nice.
And I thought that's super interesting because, why did he repost it? He doesn't, he has to, it's his product, it's his future. He has to essentially check some box that said, this person's onto the right thing here.
Yeah, of course.
So that also meant that he
never random.
No, he's not. It's very purposeful. And so he had to read part of that. And so I reread it after I saw that repost, and I thought, what would his eyes have, what would his brain have connected to in that article that saw a future that I saw?
That's the article. It's called Tesla Optimus. I know what I see, right?
I know what I see. That's the article. Yeah, I know what I see, because that was the idea. And then I was trying to, later I talked more about the network effect, but with that particular article, and that's a fun one to get into, I talked about like just the things you can do with the vision of this, this embodied AI that is insane. Like it's something that you could never, imagine that. Just give you off to my left here, you can't see it. I have bookshelves and lots of books, and I have no idea. I don't remember. I could probably recall about 2% of the books that are up there. And if you saw them, you'd think, oh, this person thinks this way. Yeah, no, some of those books are just random, and I found them somewhere. Some of them I read, but imagine Optimus walking into a room and taking full account of everything that's in that room, knowing every title that on every book, and then just because reading every one of the books, not necessarily having to pick it off the shelf, but just having access to the
database.
Accessing to the LLM portion of it, and go, okay, I have full knowledge. So my owner may have read, this book here. I'm going to go gather, I'm going to go gather all the knowledge on that, so I can have a good conversation with my owner.
I love that idea that you put on there, the group learning of the bot. But not only the bots, but also the bots and the cars.
Yeah, exactly.
That's like the exponential part of that part is amazing.
It's a bit mind blowing, isn't it? Right? I
mean, it will be amazing case if we can post that article under our podcast, so our viewers can also then read into that stuff to educate themselves for the future episode that we can have on that. And I'm so excited about that, because if you think about, for example, something like cooking, it will be an obvious thing that already that Optimus, that humanoid, will have 30,000 plus recipes only on what you can do with the broccoli, for example, right? And to have all,
exactly.
And we'll have like all the kitchens immediately sort of available at his fingertip. But I'm also curious if we're going to see then sensors for smelling, sensors for tasting, sensors that can have sort of that those softer human skills, right? What makes an Italian chef a great chef? That's in German we call it Fingerspitzengefühl that you need to have for a whole many things. And,
Yeah, I mean,
and that opens up a door of whole new opportunities and possibilities that those robots can do for us.
yeah, imagine someone says to you, "Hey," or you went out to dinner, a friend or your wife or someone, and oh, we really enjoyed that cheesecake. Okay, what kind of cheesecake is it? I don't know. There's a lot of different kinds of cheesecake, right? So you come home and Optimus is there, and you're like, I want you to make a cheesecake like this restaurant did, and it does its thing, and it says, yeah, that's the ricotta cheesecake, and they're popular in Italian culture, and maybe you never had one of those. And you say, well, can you make me one? Well, do you want one from the southern or northern region of Italy? Well, what's the difference? Well, it's this. But I can make you the one from the southern region because I have all the ingredients right now.
Yeah,
but
that's insane.
But otherwise, I have to go shopping. Okay, well, what's different from the northern region? Oh, well, it's drier, and we use a different kind of ricotta cheese or something. I don't know. Okay, great. Well, do you know where to get that? Yeah, I do. I'll send. I'll take the car.
Just send a Cybercab and another Optimus. We'll put
a delivery made, right?
Yeah, that will be amazing. My humanoid is looking for obscure ricotta cheese in the alleys of some sort of obscure store that has them.
It's a crazy thought, and then
but it will not be your bot; it will be our collective bot.
Well, that's that next point is that now it becomes part of the network, and so part of that, you show that piece on the network article of Optimus, and it creates a lot of interesting questions on what do you share back to the fleet, what are you allowed to share back to the fleet, because there's privacies and proprietariness of information. So if you train Optimus to do a certain thing as a barista in your particular espresso shop, you wouldn't want that training to leak out to every other leased bot, and have Starbucks copy it, right? So yeah, it's pretty fascinating stuff.
Yeah, love to discuss it in another episode.
Sure. Definitely. Sure, anytime.
Thank you very much, Phil, for all this information.
Yeah,
pleasure meeting you guys.
Thank you so much for coming on the episode, in our second episode of the Countdown. Perhaps even prior to the Austin, Texas Cybercab launch and the unsupervised event, we'll have to invite you another time. But you're more than welcome to join in for an Optimus deep dive. And very nice to meet you. And thank you for all the work that you put in by digesting everything and making it digestible for the layman in the community. Very valuable. Much appreciated.
Well, you're welcome. It's a pleasure to do this. It's real fun.
Thanks. That's the end of this episode. I hope everyone enjoyed, and let's get ready for the third episode. See you.